deposits $100 in a bank account at the start of each year. Take a look, start of each year, each, meaning every year she is depositing $100. She earns 4% compound interest. Work out how much she has in her bank account at the end of the third year. Alright? So just for you to visualize, when you say compound interest, meaning the interest earns another interest, and the interest of that interest still earns interest. Okay, well, anyway, so you have there at the beginning of the first year. So beginning of first year, okay? Beginning of first year of year one, she deposited $100. So at the end of the year, at the end of year one, the money will be $100 plus $100 times 4%. Okay? Or that is equal to $100 times 1 plus 0.04. Okay? So this is the money, let me just clarify, this is the money at the end of the year 1. However, at the beginning of year 2, okay, at the beginning of year 2, beginning of year 2, Mabunto, because each year, it says each year, Mabunto deposited again $100, okay, at the beginning of year 2. And at the beginning of year 2, the money is this one plus this. So therefore, at the end of year 2, just for you to understand, okay, at the end of year 2, how much is the money in the bank? This one earns interest. This $100 that she deposited at the beginning of year 2 earns interest of 4%. So that's going to be 1.04. Okay? However, this money, okay, this money that she deposited, that is at the beginning of year 2, will earns another interest of 4%. So that will be equal to 100 times 1.04 squared. Okay? Now, this is now at the end of year 2. But at the beginning of year 3, she made a deposit of $100 again. Okay? Plus this existing amount of money. So what will happen now is that at the end of year 3, this 100 earns 4% interest, while this one earns 4% again. So that will be 100 times 1.04 squared. Plus, this money earns interest as well. So that will be 100 times 1.04 cube. So this is now the amount of money at the end of third year. Okay? So that is the meaning of this part of your answer. Of this part. Okay? Again, just for us to review it. Mabinto is depositing at the start of each year. Every year, she made a deposit of $100. And then, it is compounding at 4% interest. So therefore, you need to compute year by year. Okay? So you will get a geometric progression because the interest is fixed like compound for 4%. All right? Guys, take a look with that little amount of interest, but I don't know if the bank will really give that much interest. With that little amount of interest, if you are just making a deposit of $100 per year, you have this amount of money. Okay? So it's actually a good, what do you call this one? A good habit to save even just little amount of money every year. And you will notice that if you're gonna have $100 every year, oh my goodness, that's gonna be a lot of money at the end of 30 years. Okay? Now, let's compute the letter B. Work out how much money she has in her account at the start of 30th year. Let's try to visualize what do you mean by that at the start of 30th year. Okay? At the start of 30th year, meaning the money at the end of the 29th year, let me just write it down, meaning the money at the end of 29th year, take note at the end, plus 100. Okay? Plus 100. And what is this one again? What is this one? Remember, that is at the end of the first year, that's 1.04. At the end of the second year, plus 1 plus 100 times 1.04 squared plus until at the end of the 29th year. Okay? So this is the money at the end of the 29th year. Then she made a deposit of 100. Okay, plus the 100 that she made a deposit at the beginning of 30th year. The question is, how much is her money? So as you can see from here, take a look that this is the 100 that she deposited at the beginning of the 30th year, at the start of the 30th year. And this is the money that she has in the bank at the end of the 29th year. What do you notice now about this sequence? It is actually now, it follows now a geometric sequence wherein the n is equal to 30. Look, 100, 1.04 to the power of 0 to the power of 1, 2, 3 until 29. Meaning there are 30 years, 30 terms, all in all. Okay? So, and because the 1.04, the modulus of 1.04 is greater than 0, then the formula that you're gonna use, S30, is equal to the first term times r to the 30 minus 1 all over r minus 1, which is actually this when you compute into your calculator. Okay? Guys, please be careful in reading problem solving. You need to be very attentive to the language of the problem at the start of each year. Okay? At the end, at the start of the 30th year. Alright? So, that's all for this example 12.